when you look at computers, they're sort of all over the world now, and we're finding them in all sorts of contexts, right? Now everybody has a cell phone, but you even find computers in things like microwaves and refrigerators, and they're really these pervasive devices that are out there. One of the artifacts of that pervasiveness of computers is that we're now pulling in more data than we ever had before. In fact, the amount of data that we're pulling in is growing exponentially year after year. And so one of the big areas where new modern applications are coming into play are they're finding ways to be able to manipulate this data, to analyze it, to better manage it for our purposes, and to be able to adapt to situations as they're learning trends from this data. And so these are what I like to call data-centric applications. They've really sort of taken over in the last few years, and they're only continuing to grow in popularity. Now, one of the big unfortunate drawbacks is that our computer hardware really hasn't evolved in quite the same way as these applications have. And so as a result, we have a lot of inefficiencies that are starting to show up now, where in order to work on this data, in order for applications to use all of these large amounts of data that we keep sending this data back and forth between the RAM in our computer and the processor just to be able to do some quick analysis of the data. And so what we're doing in my group, the work that we're really focusing on, is to try and identify ways in which we can get rid of this inefficiency. What we're hoping to do is to be able to avoid moving that data back and forth and actually doing some of the processing where that data is already sitting inside the RAM. And if we can do that, the power savings are actually quite large. With newer technologies that are coming out today, we can actually reduce the energy that you consume in processing this data by up to an order of magnitude. So what that means is essentially if you have a phone, in theory, you can imagine that this phone could maybe last 10 times as long as it did before by using some of these new technologies. And so this makes for a much more sustainable environment, given the amount of power that computers are consuming today. It allows us to think of new applications where computing really couldn't go before because of some of these limitations that we can now enable because we've made this intensive data processing significantly more efficient. So one area that we've been looking at, for example, has been this concept of precision medicine, where we'd like to be able to have these small devices that you can imagine just plugging into your finger, and then it'll pull a samples of your DNA, and then we'll be able to build together your entire genome and figure out in real time what specifically your ailments are, what conditions you have, and be able to determine specific treatments that are specialized to you as a person. And so this is something that requires a lot of this data movement to take place. And because of the amount of energy that it takes, it's very difficult to do this now, in such a portable device. If we can come through with some of the technologies that we've been working on, you could imagine that you can build a small little device that you can put on your finger and you can carry it around all over the world. You can take it to remote areas. You can go out to these very underserved locations and be able to do the same kind of analysis that you could in a top-of-the-line hospital today. We really believe that it's important for hardware designers to start working with application developers and trying to work together to come up with new algorithms and new hardware that work together at the same time. To me, this is sort of the new forefront of computer architecture, and it can take some effort because you have to break down a lot of these existing boundaries and often get out of your comfort zone to be able to try and think about the bigger picture at hand. But it often lets us discover cool things, and it lets us make more transformative changes that ultimately have a better impact for the general population, because it makes more efficient products, it makes cooler products, and it allows us to really be able to push the wall in terms of what we can do.